Welcome to the April 2025 Raleigh Astronomy Club class. Today we're going to be talking about narrowband imaging, focusing on data acquisition. I'm Naveen Malik. I'm one of the co-chairs of the Astronomy Club and have been actively imaging for about 4 years now, focusing on deep sky astrophotography. So before we started the class, chatting a bit with Dean, we were talking about solar imaging, and I realized after having written this presentation to give that I didn't include solar at all, which is another thing that is uh, could you definitely utilizes narrowband imaging, more narrow than the deep sky. But anyway, as we go through this class, I prefer we have that things be interactive. So if you have questions, please go ahead and ask. As I said, we're going to be focusing on data acquisition, not on processing. Hopefully go through the why all the way through the how to get set up. I may miss things. There's some other folks on the call who know more than me, I'm sure. So if I miss something you feel like should be called out, again, please interrupt. So I don't like death by agenda, but here's the gist of what we're going to talk about today. Like, why would you use narrowband filters? What kinds of filters are out there? Talk about cameras and the filters that you can use on them, and then get into a little bit of the how. How do you mount a filter, and then several gotchas and kind of tips on the way I get set up for a new rig that's using uh, narrowband filters, whether it's a color camera or a monochrome camera. So the why. The big, well, there's I'd say three ones for I'm focusing on deep sky astrophotography, as I mentioned. So three that I um, look at for the whys. Like one is the moon. When you've got the moon out, it's very bright. Talk about light pollution. It's like a huge source. It's very hard to image broadband when the moon is full or near full. So that may be one time where you would want to use narrowband filters. Mentioned light pollution, so this is the Raleigh skyline. So if you're anywhere near a large city or even smaller cities, or there's a high school near my house that lights up the southern sky whenever they have a football game. Like, lights are a real problem. This is from an example picture I took with DSLR, no filter. I thought it was pretty cool. A couple years later, I went back and took a shot with a filter, the same field, the same camera lens. So narrowband can let you pull out a whole lot more of the nebulosity in a region. So that's pretty fun. So the different types of filters. Let's talk about first the wavelengths of light we're dealing with. So when we talk about visible spectrum, you've got blue, green, and red. It's just a quick image kind of showing that. And when you narrowband, there's four. I'm sure there's a lot more band passes that you could be considering, but uh, three most common are from the right: sulfur 2, hydrogen alpha, and oxygen 3, and then hydrogen beta in the blue here, kind of an honorable mention. I've not personally used hydrogen beta for any imaging, but these are the ones you would typically be looking at for deep sky imaging. Um, and this one, we're not going to talk about spectroscopy, but I always like this particular picture. Can anybody tell me like what this is an image of? I guess. So this is the Ring Nebula. Yeah. And what spectroscopy does is it takes the different wavelengths of light and splits it so you can see them basically all. And then this has been colorized to show where it shows up in the visible spectrum, roughly, which is neat because you can see with the ring, like hydrogen alpha is extremely strong, as well as oxygen 3. You get a little bit of hydrogen beta and other things. It doesn't seem to show the sulfur 2, which it would be to the right of hydrogen alpha, and I have imaged it. So there is sulfur 2 there, but not nearly as much as the hydrogen alpha. Um, not a lot in the green there. All right. So any questions on filters, or sorry, light, and, anything we've covered so far? I'm going to talk about a little bit about cameras, filters now. All right. So the first thing I want to hit on is the smart telescopes. There's quite a few options out there. I personally have a Dwarf 3 that I've been having some fun with. I know a lot of people in the club have the C-Star S50, a couple with the S30. Steve has one of everything, I think. There's other brands out there. Celestron has some options. There's the Vespra shown on this slide. There's Unistellar, a whole slew of stuff out there. Some of these have built-in filters. So like the C-Star and the Dwarf have internal filters, so you can switch between a light pollution filter and a narrowband filter. The Vespra pictured here, I kind of picked it because it does not have an integrated filter, and we'll talk about that in a bit.
Naveen, do you know
Yes.
what the bandpass is for these incorporated filters, what nanometer they are at each peak?
I do not. I
Is it
did.
even known?
They're not a low. I mean, I think
No, I would have figured that. I figure it's not 3 nanometers. Is it 7?
I think the best would be like 12 nanometers.
Okay.
I don't think they go below 12, but they may not even be that low.
Okay.
So, yeah, but nothing, I don't think below 12. Those are too expensive, and they're not going to have them in these cheap scopes, even the expensive ones. So I would think 12 is probably the right answer, but I could be wrong. But
I was looking up the Dwarf 3 recently because I had the same question. I can't remember what I found though. It was kind of the only thing I remember was not being able to find it easily. I don't think they published, for at least from Dwarf Labs, I don't think they published the bandpass for their filters. Okay, so other cameras. So from the left, got a DSLR. There's also mirrorless cameras. I just picked this from as a stock photo. There's lots of options. Not saying I'm a preference for Canon or anything. On the bottom, it's funny. I was going to have the color and the monochrome version of the ASI 2600. They look identical, like from the outside. So on the bottom is the 2600 MC, which is the one-shot color deep sky or an astrophotography camera from ZWO. Top right is the Zeus 455M, so a monochrome color, monochrome camera. Cool. So talking a little bit more about those filters. So you have the built-in filters, as we just discussed. Don't know the band passes for them off the top of my head, but one of the other options is, for the Vesper, you don't have an internal filter. You have external filters that you can clip onto the front, which is shown on the left side here. I've seen, and this is an example on the right, even for something that has an internal filter, people have made adapters to put a filter on the outside.
yes.
So you can 3D print something, put it on the outside, screw in your 2-inch, in this case, probably a dual band filter of some sort, and see what you get.
Naveen, the H alpha on the C-Star S50 is 20 nanometers, and the oxygen is 30. So they're not very narrow at all.
Not at all, no. Okay. So that might be a reason why you might want to try an external filter or try your own filter, something with a narrower bandpass to reduce the light pollution a bit more.
Yeah, Naveen, it's also in solar. You can use an external, a better external filter than the solar one that comes with the C-Stars. And that seems to give it a bit more detail if you do that.
Okay, that's good. I've dabbled just a tiny bit with the solar filter that came with my dwarf. That's a good point. Have you tried, Steve, using external filters for any of your smart telescopes?
Yes, I mean, I've used the Optolong for the sea stars, and I've used a Bader filter for the dwarf and the sea stars, and they all seem to work a little bit better than the internal ones. But of course, you have to spend the money on them, so I'm not sure they're that much better.
Right.
Yeah.
Spend $500 on a smart telescope,
Well,
spend what,
not only
$300
that,
filter.
with the 10 to 30-second exposure, if you put a really
Mm,
good narrowband filter on any of these things, you're not going to get anything because you can't go beyond 30 to 60 seconds or something like that, and that's not going to work very well unless you have a very
yeah.
bright, like Orion Nebula or something maybe, but a lot of other things is not going to work for now anyway.
Okay. So on from, well, any other questions, comments on smart telescopes? Going to move and look at color cameras next. All right, so the first thing I want to make sure, like, set the context. So color cameras there's a filter mate on the sensor called a Bayer matrix. Typically, it's red, pattern is red, green, green, blue. But anyway, it's a 2x2 matrix repeated with 2 green pixels, 1 red pixel, and 1 blue pixel. And the reason for this is historically, cameras were used for terrestrial imaging, and our eyes perceive green a lot better than red and blue, so there's a bias towards the green. So it's important to know that when you're talking about a camera that's color, you always have this matrix of little micro filters on your sensor that you can't get rid of. All right, so that context set. So one of the things you can do is you could still try to cut out, infrared or ultraviolet, depends on your sensors. There's like a protective glass, thinking like a DSLR. You can have a DSLR modified to remove the the protective glass and replace it with something that's just transparent to all light. And that would show you everything you would be catching ultraviolet and infrared light. So you could still use a ultraviolet and infrared cut filter to cut that out. And this graph shows how you would still be seeing visible spectrum plus up through hydrogen alpha and a little beyond, but nothing above around, I guess, what, 700 nanometers. You can get a light pollution filter. So these are going to focus in around, like the hydrogen alpha, sulfur 2 region for red, and then straddling blue and green for, that hydrogen beta, oxygen 3. Different light pollution filters have different spectrums, what they'll show. Some let in a lot more. This one's pretty well constrained. This may be similar to what you would see in the smart telescopes, and they're pretty broad, pretty wide. And then you've got your dual band, tri-band, and quad band filters. The more common ones are the dual band, where you're looking at 2 different band passes. And I've put in parentheses kind of what I've seen around as being pretty common. The ones that I've personally used have all been hydrogen alpha plus oxygen 3. Because remember, we still have that Bayer pattern on the sensor. So you're still, hydrogen alpha will show up with red pixels. Oxygen 3, if you look at the graph, shows up both green, mostly green with a little bit of blue. I toyed with the idea of getting a sulfur 2 and hydrogen beta filter with my one-shot color camera, because then you could, again, sulfur 2 is red and the hydrogen beta would be blue. Could easily separate those colors. or there's sulfur 2 and oxygen 3. Tri-band filters, I've not used one, and I've kind of wondered about the value in them. You could see probably maybe you can split hydrogen beta and oxygen 3, because between blue and green respectively. And then you'd have your hydrogen alpha in red. The really weird one for me is the quad band filters. So you have both sulfur 2 and hydrogen alpha. You can't, it's red. There's no separating. Once it hits the camera sensor, it just shows up on a red pixel. So personally, it doesn't make sense to me because I want to be able to split the two things, the colors apart, or the band passes apart. Steve, have you or anybody used like tri-band or quad band filters? Any experience with them?
The answer is yes. I have the L Extreme and the L Ultimate from Optolong, and they do a nice job. The 2-inch filters on one-shot color cameras, on my astronomical cameras, not on DSLRs, but
those are dual band, right?
I think the Ultimate is tri-band.
Is it? Okay.
I believe it is. I'm going to look it up right now, but I think so. But
okay.
I've found the Ultimate, just because it has a narrow pass on these things, it does a better job than some of the previous ones.
Yeah.
So, yeah.
Okay. I have used some hydrogen alpha, oxygen 3 dual band filters on a DSLR, so it can work.
Yeah.
Quite well. The trick is, of course, like how well your camera responds to hydrogen alpha if it's a DSLR thing. When I started off doing astrophotography, I was using a Canon SL2. It had almost no response to hydrogen alpha, so my first picture of the Rosette Nebula was very rough. Okay. So on from color to, okay, well, first form factor. So if you have a DSLR, there's clip-in filters or a mirrorless camera. You can get a camera and clip it into the body before you put a lens or other optics onto it. And then typically for threaded filters, I've only really seen people using 2-inch filters. I guess in theory you could use a smaller filter, but it may depend on, but definitely would depend on your sensor size. We'll talk a bit later about how you get filters into the optical train to actually use them. First, talk about monochrome. All right, so a monochrome camera, we don't have a Bayer matrix. Every pixel gets every photon, well, any photon that hits it. It's not going to be filtered out, at least within the camera. There may be a integrated UV-IR cut filter if you're talking about, well, it's monochrome, you're generally talking about an astrophotography camera. Some of them don't have any filtering at all, so you would want to have luminance filter or a UV-IR cut filter still. One of the reasons for this is that star shapes will be a bit bloated, a little bit fuzzy, and not as sharp as they could be if you don't cut out ultraviolet and infrared. So also for broadband, of course, you've got your red, green, and blue filters. Again, you'd have one filter at a time, capture red, change it, capture green, capture blue, one at a time. Then you have your narrowbands. We've seen this picture before. Sulfur 2, hydrogen alpha, and oxygen 3 are the common filters for monochrome imaging, the deep sky. Hydrogen beta is not as common, but I guess would be the next one you might pick. Beyond these, there's also planetary imaging, which uses different sets of filters, and I don't have any experience with that to share what types of filters you might use there. But we'll look at a filter wheel later, which is really necessary for monochrome imaging, and we'll show why hydrogen beta may not be super common.
Naveen?
Yes, Anne.
Yes. You're not showing slides, right? You're
Yeah.
just reading.
No.
I'm not seeing the slides. I see you,
I hope
but
everybody else sees slides.
does everyone else see slides? It's just me? Okay, maybe I'll
And
log off and come
look
on
at the
again.
top of your Zoom window. You might have
Uh-huh.
two tabs, one which has the people and one that has the slides.
Okay.
See if you have that.
Oh well, oh here we go. Maybe it's Galaxy Gallery. No, that's not it. Okay, I'll fiddle with it. If you're showing the slides, then I'll fiddle with it. Thank you.
Yep. Okay. Monochrome filters, form factors depend on your sensor size. 2.5, there's threaded filters typically in 2.25 inch or 2 inch. And then there's unset filters typically in 36 millimeter. So your 2-inch filters, if you have a full frame camera, you're gonna have to use 2-inch filters, otherwise you won't be able to cover the entire sensor. 36 millimeter filters are used typically for an APS-C size sensor. And then stuff smaller than that, you can use the 1.25 inch. I recently got the IMX 585 sensor, so it's kind of like the way I think about it, at least the size of the sensors. You take basically a 1-inch diagonal sensor, which would be like the 533, and you cut it in half. So it's a pretty small sensor, and it works well with the 1.25 inch filters. There are some square filters out there, and I know the QHY for their what is it called? Minicam 8. It has like its own custom filter wheel with custom sized filters. They're like rectangular, just as big as they need to be. So they're proprietary. So these are more about the standard, typical filter sizes. All right, I'm going to get into how you put the filter into the imaging train. I just have some pictures to talk through. On the top left is an example of a device you can put in between your camera and your telescope, where you could just thread a filter straight into it, like a 2-inch filter. Some telescopes have a place where you can thread a filter in, so you may not need to have anything new hardware-wise in order to mount a filter. It becomes kind of tedious to change the filter though. So on the bottom left, there's a device called a filter drawer. And you put the filter onto this drawer thing and just slide it in, and then you can pull it out easily and either change the filter on the drawer or have multiple drawers to be able to swap between different filters. Maybe you use a UV-IR cut filter for broadband imaging for a color camera, and then when the moon's out, use a dual band narrow filter. Switch between them. On the right is a filter wheel with different carriages, and this is from TubeTech, and I liked it because it illustrates one of the challenges with the size of the filters. You see the top right is a 2-inch filter. Can only fit 5 on there. I've not done any imaging with 2-inch monochrome 2-inch filters. I don't have a full frame camera. So I haven't dug deep to see like if there's a filter wheel that would support more, but like what I like in a filter wheel is at least, luminance, red, green, blue, sulfur 2, oxygen 3, and hydrogen alpha, which is 7 filters. So full frame imaging has some potential challenges. In the bottom left, you can see the 36 millimeter filter wheel carriage has 7, so that would work great for an APS-C sensor. That's what I've used for quite a while. And then the 1.25" has 8. So the filter wheel I just set up for the small sensor that I recently got. I 3D printed a blank to put in the 8th one, so I can take darks by just going to the 8th slot pretty easily. It works pretty well. I still like make sure it's dark around it and all that jazz because I don't trust that it's blocking everything, but I don't have to find the the cap for the end of the optics to block it off.
Naveen, I have a comment about the 736 millimeter one. When
Sure.
you're putting in your filters, make sure you're wearing gloves.
Mm.
Because it's very hard to put the filters into these things properly without getting smudges all over them. So
Yeah, that's a good point. So as we said earlier, like the 1.25" and 2" are threaded, so you have something to hold on to and screw it in. The
exactly.
36 millimeters not threaded.
No.
It's just a disc.
And then you have to put little holders on and little screws, and it's quite an effort. So be prepared for that. It's the best thing to use, but it's very hard initially.
It's tedious, yeah.
Yeah.
Um,
Can I ask a
thankfully,
question?
Yes, Lewis.
So, you said you put a black blank in there. Does it matter that you don't go through the whole train? Because the filter's right in front of the camera, right? That's what I always wondered.
What do you mean? I'm sorry.
When you're shooting darks,
Yeah.
if you are using a black in the filter wheel, it's right in front of the camera.
Right.
If you're not, it's going all the way up to the end, usually with the cap. Does that make any difference?
Still not quite following, but
For darks, you don't have any light coming through.
So it doesn't matter? That's what I always wondered.
It doesn't, for darks and biases, it's just camera sensor stuff that you're getting. So it doesn't really make much difference what the rest of your train is.
Okay, that's what I always wondered
You don't
about.
have lights coming through your train. It's only, so you could put it pretty much anywhere. It's in some ways, because you can have light leaks in your train. Okay, it's almost better to have it closer to the camera, but you can even have light leaks in the camera. So you have to be careful about that if you have a camera that needs darks.
Okay.
Does that make sense?
Yep.
Okay.
It was just a question I always had, though.
Yeah, so as I take the darks with the set in the camera wheel to that 8th slot. That's like an opaque plug, but I still make sure it's a dark environment. So on leaks in cameras, somebody in the club, I believe Marshall, was talking about one of his cameras. He was troubleshooting a light leak, and it was in the camera body itself.
Yeah. Sometimes it comes through the where you're looking through the camera. I forget the name of it now.
Where the cooling,
all that.
pins
Yeah. So you have to watch out. So put something around the camera that's going to block the light as well.
Yep. Okay. All right, so on to kind of gotchas and tips. I'm sure I won't have every possible thing in here, so if others have some things that have bit them in the past that I don't have listed, it'd be great if you could share. I'm going to start with kind of the things to keep in mind. You need to take flats for every filter, because the profile of light's going to be different. You could have different vignetting. Of course, it's filtering different wavelengths of light. And then the other thing to remember is if you are not using a filter wheel, EFW is electronic filter wheel. If you're not using a filter wheel, meaning you're changing the filters with a drawer, or you have to take the optical train apart, like take your flats before you change to the next filter, because even if you have a filter drawer, you're potentially introducing dust onto the filter, and that filter is very close to your sensor. So the dust will show up. And you want to capture the dust on your filter with flats like the same dust that was taken for your lights, so that it can calibrate out. Otherwise, you'll have weird splotches on your image, which nobody wants. Clip-in filters, and if you have a way of like a screw-in mount, it will require disassembling the optical path. It is tedious. It is possible. I used to clip in with my DSLR for a while. It was an Optilong L Enhance. It was fun. Totally worth it with the DSLR. Got some really neat stuff, but I didn't want to have to change it. I mean, you take it out so I could do broadband. Some filters will have halos around very bright stars. So do your homework, ask around about people's experiences with specific brands or specific filters as to whether or not they've seen halos, if you care about that. I have an L Extreme that is older at this point, and it has a lot of halos for hydrogen alpha. And I used to not care, but my tastes have changed and I care about it a lot now. I think that things have progressed through the years too. So a lot of the more like modern current filters, probably not as bad, but still do your homework. For narrowband, you need a longer exposure. As Steve was saying earlier, if you put, like for these smart telescopes, if you put a very narrow band pass filter on the outside, something you bring and adapt, you're going to have challenges collecting enough light within the maximum exposure time. I'm typically for narrowband taking 5 or 10 minute exposures for narrowband images for non-smart telescope rigs. Which brings another problem is with longer exposures, because you just need more light to hit the sensor before things are registered as being a star. Your focusing is going to take longer. So if you have a filter wheel, you can do filter offset. So you basically, and I'll have some tips on how I do it later on in the slide, is you focus with a filter that's going to be quick, like your luminance filter, and then you know relative to that filter how much you need to change your focus on either side whenever you change to any of your other filters. So you can really speed up, optimize your imaging time. Not required, but it's, nothing comes for free. There's challenges with everything. So I've had problems with filter wheels introducing issues for guiding. I use an off-axis guider. So that means it's off. Okay. So you have an image circle, like the light coming into your telescope, and I have an off-axis guider has a prism that picks off some of the light on the edge that you're not using for your main image. And there's a camera watching that instead of having a separate guide scope. Because it's all within the same optical train, when you change your filters, the guiding is disrupted. So you have to be mindful of that. And then even when not using an off-axis guider, having a separate guide scope, I've seen the vibrations of changing the filter cause guiding to go wonky. So, and then the last, well, not last one, but second to last, the bandpass shift. So if you have very fast optics, you have to be mindful of the width of the bandpass for your filters, because the fast optics, basically the bandpass shifts. So you might move off of what you're actually trying to collect data for, or reduce the effectiveness of your filter for the particular light that you're trying to collect. There are filters that are built for this, though, and I've used some with the faster lens, and they're great. On the flip side, I've also used a non-fast optics filter on a fast lens, and it worked okay. It wasn't the best, but it worked. So something I'll always say if somebody's like, wonder if I should try this. I'm like, yeah, try it. Try before you spend money. Try figure out like what do you have currently? Give it a go. If it doesn't work, okay, then you can look at options. But and then the last one is filters cost money, especially if you get into monochrome imaging. Mentally, my mental model is take the price of the camera, and that's at least what you need to spend on filters. So it's camera times 2. So, anything else that Steve, I know you've done a lot of imaging with all sorts of different setups. Any other tips?
Well, the
Gotcha.
only thing I'd say, if you have something like the ASI 2600 MC Duo, for example, can guide through that. And there was a lot of debate about whether or not it would, with narrowband filters on that one-shot color, whether you could actually guide it or the filters would mess up the guiding stars. And the answer is no. I've had no trouble guiding with the one-shot color narrowband filters. It's just fine. But you do need the at least 2-inch or 36 millimeter filters. Well, in this case, 2-inch filters on it, because a smaller filter you will not get the stars that you need.
It'll constrain the light path too
Yeah,
much.
exactly.
Mhm.
So if you decide to get a thing like the Duo, which when you're beginning you probably won't, you need to worry about that. And I think like the Mini Cam 8, the QHY one, you're not gonna be doing that kind of guiding. You're gonna have to do external guiding. But you can set up your system so that it waits a while after it switches filters to start the guiding again. And typically the modern software will do that for you. So any vibration you get from switching the filters will go away if you give it 5 or 10 seconds or something like that to settle down. So there are a number of little niggly things you learn when you're doing this kind of thing. So,
Do you
and
have to take longer guiding images for the
I have not
Duo?
had to. I have not had to, strangely enough. But there was a lot of debates. It would never work and never work. But then I watched a lot of YouTube videos on this particular camera, and they said it's fine. And so after I got mine, I tried it, and it was fine. I've had no trouble with guiding with that kind of camera. So yeah. Uh, let's see. The other thing is the on the narrowband filters, the band pass. Right now, 3 nanometers seems to be the most expensive, most narrow part of it, and they do a lot better than the 5 or the 7 or the 12 nanometer ones, but they're way more expensive. Every single once, at least right when I bought them, every 3 nanometer filter was $750. So, and you need 3 of those. So, and then the filter wheel on top of that. So you're talking more money than you spend on your telescope or your camera by a lot just for the filters. So start out with something like the mini cam or something like that, where you're spending less than 1,000 and getting everything. And then if you really like doing it, then move up to more expensive stuff. So yeah, it's a real, can be incredibly expensive if you're not careful.
Yeah, can one of you guys explain why I should get a 7 or a 5 or a 3? I mean, what's going on with this?
Naveen, you want me to say it, or I'm
Well,
I've used all of them, and every
go ahead,
time I
Steve.
got a better one, I got better contrast, more detail, that kind of thing. But also I had to expose for longer and longer times. So with the 7, I might be able to go 3 minutes. With the 3, I would have to go 5 minutes minimum. And depending on the target, sometimes 10 minutes. So you're gonna have to be able to guide really well when you start getting narrower and narrower filters. So that's the main problem. And then you're going to have to take more exposures over a long period of time. So you might only do 1 filter per night or something like that. You have to figure out all these things. That's why one-shot colors with narrowband filters are very popular, because you can do one target and all the frequencies in one night. And that can be more pleasant if you live in a place like we do where there's lots of clouds. So it really depends on how persnickety you want to be with your image. But narrowband is going to monochrome narrowband is going to give you a way higher detail picture ultimately, and you'll see way more subtle details and things. I've done it. I've done one shot color on a target and then narrowband on a target, and it's almost like they're different targets, just because you get so much more detail with the monochrome narrowband. But it's a lot more work, both in taking the images and processing them. So, but it's worth just starting out with something that's not so expensive to see if you like doing it, like processing, and then if you really want to get better, then spend the money to get the better filters and all of that. So, and a filter wheel is fantastic. It's much better than trying to switch filters for flats and for other reasons. If you want to automate things, especially if you don't stay up all night like I do. So
You
anyway,
mentioned
yeah.
trying out in the processing side of things. So just to throw out there, if you're not sure if you want to if you're going to like the processing side of that, because that's the other half of this equation is like you collect the data, but then you have to do something with it. The data from Hubble and James Webb and other telescopes is available. You can go grab it and deal with, you know, the processing, at least as, you know, their master lights that they give you, and it's a lot of fun. Personally, I really enjoy it. So it's a good way to just kind of try it out with some data that's really high quality. Because there's quite a learning curve there as well. Okay. I just had a couple other slides on some things that I keep in mind when, you know, setting up a new rig that I thought might be useful to share and spur some conversation potentially. So I was talking about filter offsets. So when you have a lot of filters to focus with, even if you're using one-shot color, and even if you're using like a filter drawer, if you're switching between filters, you know, maybe multiple times in the night, and you might want to do this. But for my monochrome imaging, I set up filter offsets and my routines to find focus with my luminance filter, because that's typically the reference, because it's the one that's going to be collecting the most light, therefore can have the shortest exposure time. So the theory is that it would be the quickest one to autofocus with later. I then take a note of how many stars I see in a particular frame. And for every other filter that I have, I'll find focus, and then I'll find the exposure time that gets me close to the same number of stars, or at least kind of, you know, finger, thumb in the wind, whatever, sort of kind of close. Because one of the challenges is we've been talking about the narrowband filters, you have to expose for longer. So even though you might see some stars with your hydrogen alpha filter with a 1 second exposure, may not mean it's enough stars for autofocus to be really good. So I kind of use that number to then set up my autofocus routine to say, like, you know, luminance is 1 second. Which is kind of typically what I end up with is luminance is about 1 second. Red, green, and blue are probably 2 seconds. And then hydrogen, sulfur, probably 10 seconds, maybe closer to 15, depends. And then oxygen 3, at least for my SCT, is, I think I set it to 10 just to be consistent, but I think 5 would work as well. It's a little different than the other two. It catches more. But then I use Nina, and there's a focus offset plugin that'll just run through every filter 3 times and then tell you, like, hey, these are the offsets. What do you want to use as your reference filter? You want to use absolute values, or do you want to do relative offsets? And you just set it up. And I assume other software has similar capabilities. I have no idea what the ASIR can do. Sorry, haven't used it. But then the benefit is like anytime you need to focus, it'll switch to your reference filter, run the focusing routine. This is assuming an autofocus. And then before imaging, switch back to whatever filter you're going to take pictures with. So instead of sitting there waiting 5 minutes for hydrogen alpha to focus, done in a minute or less or whatever. So does anybody know how the ASIR handles filter wheels and this kind of stuff?
I have not tried this. I mean, I use it all the time, but I have not tried this because I haven't done that much with my filter wheels because they're doing mostly one-shot color, but because of the clouds and all of that. But it does have some facility for that. I don't think it's as sophisticated as Nina, though, at least not right now. So if you want to really be sophisticated, use Nina.
Does it allow you, do you know if it allows for setting filter offsets at least?
I think it does. Yes, I just have
Okay.
not done it.
Okay. So I mean, worst case, maybe you have to manually figure out what the offsets are.
Yeah.
Okay. That's not terrible. All right. Another thing that I go through whenever I set up a rig is how long of an exposure do I need to take? Again, I'm Nina user, so there's an optimal exposure plugin, and it can use the sensor analysis that SharpCap does. And I recently found out you can do sensor analysis for free in SharpCap, but to use the results of that analysis outside of SharpCap, you need the license, which is not a lot of money, but it's totally worth it. Oh, they have a lifetime license now, which is nice. So I will do the sensor analysis in SharpCap, which, for different gains or ISOs to figure out what the noise of the sensor is and the bit depth and all the other groovy stuff. Nina can reference that and then find focus with every filter. If you have your filter offsets already set up, use the optimal exposure calculator to figure out what it thinks you should be taking. I usually do I've tried for broadband like 5 seconds, and then it doesn't seem to matter if I go with 5 seconds or longer for the narrowband. So I've just stuck with 5-second exposures for now for the calculator, but it's pretty interesting. Luminance is usually extremely quick. Color filters a good bit slower, and then narrowband could be such a long exposure that I'm like, yep, not going to do that. We'll go for shorter. So I have a Celestron C8 that I'm using right now, and for the camera, I have my luminance. I think it said I should take like 10-second exposures or less, which is ridiculous. That's so many files. Color filters are 30 seconds, between 30 seconds and a minute. I can't remember exactly what. Hydrogen alpha, it said I should do 1200 seconds. At which point I'm like, yeah, no. There's so many things that can go wrong. So I take a shorter exposure, but still pretty long. So that's one thing to keep in
What
mind.
camera are you using, Naveen, for the C8?
That's the 2600 mm.
Okay.
I'm running it at f10 right now too, so everything is very slow. Yeah. So we've talked about being limited on the exposure time for the smart telescopes. It's true for other rigs as well. If you have not guiding perfectly, or gusts of wind can blow your rig around a little bit, take that into account when you're setting your exposure time. I can't remember if I had anything else. Oh, right. Offset. The setting that nobody thinks about. Anybody know what offset does? when you're taking an image, the offset is basically setting the floor, like what is zero? So instead of it being literally zero in your sensor, you can move it up a bit. And the reason why you want to do that is like for broadband imaging, it doesn't matter. You're collecting light so fast, every pixel is going to register some data. So it's always going to be above whatever that floor is. When you're doing narrowband imaging, it's possible that you will have zero values on pixels, which is weird. And when you integrate, you can end up with like little tiny black holes, like little specks that are no data whatsoever. So what you do is you put an offset into your imaging to bring that floor up off of zero, and you have wiggle room. And took me a while to do this, and I was playing around with the rig a couple years ago and compared data before and after having set an offset, and it was a easily noticed difference. Looking at the like the whole image, it was like there's like little specklings of dark in before tuning the offset. So something to look into if you're doing narrowband imaging. Every time I do this, I kind of have to reinvent in my head, like figure out how I did it before, because I had, for some reason, not written it down a whole lot or well enough for me to remember. But basically, take images at some offset, count the pixels that are zero, and if it's more of them are zero than you like, bump the offset up. Try again. It's not super intense. It's slightly tedious, but I use PixInsight, and this is the pixel math I use. The plus equals in there will report the result into the logs, the process log. Yeah, and then once you set it, and this is why I hadn't written it down until very recently. Like, keep that set for that camera for all time. I think that was it. Yep.
I got a question. How do you determine which filters you want to use for which targets? I mean, I understand there's emission, reflection, nebula, and you got galaxy with those nebula in it.
Sure. There's the try all your filters and see what you get option, which I do sometimes because, well, think about like the Ring Nebula. It's a planetary nebula. As we saw in the spectroscopy image, like it's heavy in oxygen-3 and hydrogen alpha. Most planetary nebula are, and most of them, usually you would image them in only those two band passes. I was like, well, maybe there's some sulfur too. So I gave it a go. And there's a nice ring of sulfur too that gives some nice structure. So I'm like, okay, I spent the time to collect some sulfur too for ring. But you can, emission nebula is going to be hydrogen alpha. Planetary nebula are typically hydrogen alpha, oxygen-3. Reflections broadband. You're going to find oxygen-3 also in emission nebula. But I try them all. It's like spend an hour on each of the narrowband and see what I get. Like my background image is Rosette Nebula, part of it with it's a SHO image. There's not a lot of sulfur too. It's very faint, but all the little tendrils, all the faint structure that's in this image is because I spent almost 40 hours on sulfur 2 because it was there and it kept coming out more and more. I'm like, it was really cool.
Oh, cool.
Yeah, Dean, the picture behind me here, the Orion thing, is an SHO as well. Okay, without the S, a lot of this structure that you see below the horse head here didn't show up very well. Okay, so when I added the sulfur onto it, it really popped out more than it would have without it. Okay, but what I was going to say, the real way is to cheat and go to Astrobin and look up the target you want to do and see what they used and
Sure.
see how many hours and or whatever minutes they put on each filter. Okay, and what kind of filters, and that will give you some idea whether or not it's worth, whether they thought it was worth doing lots of different filters or not. Okay, so that's just see what somebody else has done on a given target. That's the fastest way to figure it out rather than even trying it yourself. Though trying it yourself's a lot of fun. If you really don't want to waste the time because we don't have good skies, go to Astrobin and look it up and see what people do.
That's a good point. Any other questions, comments?
I think that's good advice because at least you have it. It's a place to start, especially if you're getting frustrated and you're not getting it. So at least it's a place to start. I like that. I like that piece of advice.
All right. Well, we are right at 2 o'clock, right on time. Well, thank you, everybody. This was fun. I appreciate the time.
Thank you, Naveen, for taking the time to put this all together for us. It's great.
You're welcome.
Thank you.
See you all online. Cheers.
Yep, absolutely. Thank you.
Thank you.